Welcome. Today we'll solve a calculus problem involving velocity and position. We have a particle moving along a straight line with velocity function v of t equals t squared times e to the negative t. We need to find the position function, s of t, by integrating this velocity function. Let's start by understanding what this means graphically. Here's our velocity function plotted over time. Notice how it starts at 0, increases to a maximum, and then decreases, approaching 0 as time increases. To find the position function, we need to integrate the velocity function with respect to time. Remember, position is the integral of velocity. Mathematically, we write this as s of t equals the integral from 0 to t of v of tau d tau, plus the initial position s of 0. Let's substitute our velocity function. We get s of t equals the integral from 0 to t of tau squared times e to the negative tau d tau plus s of 0. This integral requires integration by parts. Let's recall the formula for integration by parts. The integral of u dv equals uv minus the integral of v du. For our integral, let's choose u equals t squared and dv equals e to the negative t dt. Then du equals 2t dt and v equals negative e to the negative t. Applying integration by parts, we get negative t squared, e to the negative t minus the integral from 0 to t of negative e to the negative tau times 2 tau d tau. The remaining integral needs integration by parts again. This time, let u equal tau and dv equal e to the negative tau d tau. After completing the integration and evaluating from 0 to t, our final position function is s of t equals negative t squared, e to the negative t minus 2te to the negative t minus 2e to the negative t plus 2 plus s of 0. To completely determine the position function, we need to know the initial position s of 0. This would be given as part of the initial conditions of the problem. For example, if we know that s of 0 equals 0, then our final position function would be s of t equals negative t squared, e to the negative t minus 2te to the negative t minus 2e to the negative t plus 2. Let's visualize what this position function looks like when s of 0 equals 0. Notice how the position increases over time, but at a decreasing rate corresponding to our velocity function that we started with.